This video is going to review looping structures, and we're just going to go ahead and talk through advantages of looping, the components again, what a nested loop is, common mistakes, and a few other things. So remember that a loop is a structure that repeats an action, and as long as a condition for repeating the action is met, the loop will continue. Looping advantages for looping include that it makes the program more efficient and worthwhile. It also allows for one set of instructions to operate on multiple sets of data, and that's a huge efficiency thing. It also helps with modularity, because we can write modules to do these tasks repetitively. Remember that every loop has exactly three parts: the initialization, the guard, and the update. If we take a look at our bubbles example, and we take a look at a typical for loop here. The for loop has a built-in initialization inside. That's the initialization where you set what we call the loop control variable to an initial value. It has a guard, which is a question that determines whether the loop will be executed or not. As long as this condition is true, then this for loop will be entered. That's the guard, and it always uses that loop control variable. In this particular instance, num is what we call our loop control variable. And then you have the update, and in this case the update is num++, which increases num by 1. So you have an initialization, you have a guard, and you have an update in every loop. In the for loop, it puts all of those components in this one succinct statement. In a while loop, if I scroll down, a while loop still has an initialization, a guard, and an update. But that guard and the update and the initialization are all on separate lines. Initialization in a while loop or a do while must be outside the loop. In the while, you also use the loop control variable. That doesn't matter what type of loop. That loop control variable is used in the guard. And then in the update, you have to update that loop control variable. So it looks a little bit different in a while loop or a do while than it does in a for. Okay? So those three parts you should be able to identify. You should know the difference between a definite and an indefinite loop. This is different than an infinite loop. A definite loop executes a predetermined number of times. It's a counter-controlled loop. The loops that we just looked at were definite loops. I know it starts at 1 and it goes to number of bubbles. Same thing down here. I know I start at 1 and I'm going to go to 15. So I could calculate how many times this loop is going to execute before I ran it. An indefinite loop is almost always kind of like a game situation, or where you're going to ask the user, do you want to run this play again? And you're going to say yes or no. And so you don't know how many times that you're going to run that loop. So an indefinite, it is not known, or you don't know how many times you're going to execute it until the program actually runs. That is different than what we would call an infinite loop, which is a loop where the loop guard or the update was not met, and so it continues to run forever. You can increment and decrement in a loop. These lines of code show some incrementing. You don't always have to increment by 1. As you saw in the looping practice exercises, you could increment by 3s if you wanted to, or you could increment by other values, and you can decrement, which means you go down. Nested loops are loops within loops. You don't see a lot of them in Greenfoot, but you can think of the act cycle as a nested loop, in that the act cycle runs all the time, and inside of that we have individual methods that call their own loops. Okay. There's also some examples in Greenfoot Simulation Chapter 11, and maybe I'll stop and open one of those up so we can look at it. This is the foxes and rabbit simulation from that chapter, and it simulates rabbits and fox population and how those populations might coexist. And you can see that some of them die out while some of them keep populating. If we go to the code, though, that's what we want to look at here, you can see nested loops. This is an example of a for loop within a for loop. And so you can have loops within loops, and in this particular one, it talks about creating the probabilities for foxes and rabbits and those populations. So that's an example of a nested loop. You can find other examples out online too. And so this is just showing you that the ACT method is a continuous loop, and inside we have a loop that grows the population of the rabbits. And I didn't realize this was my slide that I had next. But that's actually a little bit different because it didn't show like nested fors. This is using the ACT cycle, and then there's a for loop inside of that. The other screen shows a more typical nested loops. Try when you're using loops to avoid the common mistakes, which is forgetting to initialize a loop control variable and forgetting to alter the loop control variable. If we go back to our spaces example here, some of you guys did all of your loop for example, in one of these, and you started with a new while loop here, and you did like while num and was less than or equal to 15 again, and it kept throwing an error, and you couldn't figure out why it wasn't drawing the new set of bubbles that you were supposed to do, and that's because we forgot to reinitialize that loop control variable. And so initializing that loop control variable is often a mistake. Another mistake is forgetting to increment that loop control variable, which would be in here. And also a very common mistake is reversing this guard. Instead of doing less than, you would do greater than or equal to. And so that's also a very common mistake. And those are on the next few slides here, some of them. So this one is forgetting to, the loop control variable is not altered in this program. This is some pseudocode, so it never quits. Those are the same things I just talked about. And another example here is that you're doing the wrong comparison. Instead of a greater than, you have a less than. The next few slides talk us through some of the loops that we've already kind of looked at. Just know that the for loop is considered to be a pre-test loop, and it is a definite loop. The while loop is also a pre-test loop. And then you have post-test loops. A post-test loop is the do while. Loops are commonly used for writing out business reports. We haven't done that in this class, but they're commonly used for that. Totaling game scores, we have seen them do that. Loops are also commonly used for what we call accumulating, and you should know the difference between a counter and an accumulator. A counter will increment by 1, where accumulators increment by some other value. So in your games, you guys are accumulating points. So those would be accumulators, because it's not how many times the person wins or gets points, it's how many points are being totaled or accumulated. So your adding points methods that you guys have been writing in your programs are an example of an accumulator. Counting would be more like with the bubbles, where you put 21 bubbles on the screen, you're counting the bubbles because you're going up one at a time. Loops can also be used to do what's called defensive programming, and that helps prevent people from entering bad data. This often happens when you're prompting for data and you enter a phone number wrong, for example, and it comes back and says, sorry, but your data was not in the correct format, please re-enter. And so you can't get past that screen until you enter the data in the correct format. Validating data is another common use for loops. And that would be, for example, if I want you to enter a value between 1 and 12, you're going to put that in a do while loop. So say something like, please enter the months between 1 and 12, and you do not let them out of that loop until they have executed that. And then garbage in, garbage out is a phrase that we often use, and that's related to defensive programming and validating data. You want to do defensive programming and you want to validate data so you don't get garbage in, garbage out. And that just means that if you don't, if unvalidated input will result in just some erroneous output, which means doesn't make sense. Okay, the output makes no sense. These are some other examples here of reprompting. Just please enter the month until you get it correct. And if you take a look at the code right here, it says as long as the month is less than the lower month, or month is greater than high month. And please look at how they use constants up here. High month and low months were set at 1 and 12. So this is just going to continue as long as the month they enter is smaller than 1 or greater than 12. The the program is going to be stuck into this loop. This would be considered a do while loop. It's going to do that until it it's actually going to be a while loop because the condition is before the loop. So if it was a do loop, then the condition would be after the loop is executed. So here's the pseudocode up here. This is a while loop. And it's just written as pseudocode. Some same things we just kind of talked about there. Common loop applications, validating for reasonableness and consistency of data. Those are called good defensive programming techniques. And then there's the summary. So when you take your quiz, you will be asked about most of the things that are on this PowerPoint. You will be also probably given some code snippets like here in space or some other, and you might be asked to predict the output from a loop. So that's similar to the loop practice that you guys have done in class. You can use your sheet of notes. So if you do have your sheet of notes completed from chapter 5, that's the sheet that looks like this. Then you can also use those on your quiz.